Hello guys, it's Boris here. I hope you're doing really well and you're healthy. Today let's solve some problems on LeetCode. Uh, we should try this to some problem. Why this problem? Because you can see here it's easy. It's easy problem, right? But the acceptance rate is only 54%, so it's not so easy. So what we have here, we are given an array of integer of nums called nums and an integer target, so those nums here, an array, and a target which is a number, and we should return the indices of the two numbers such they add up to a target value. We should use two numbers and return the indices. That means if the answer here is 2 and 7, we should return the indices here 0 and 1, right? And you can see the output. In this case, we should return 2 and 4. And this will be 1 and 2, right? And here they tell us that we cannot use the same element twice, and we have exactly one solution which is unique, because we can do this way the answer. We can say, hey, we have 3, and we add it to the target of 6. This is not correct because of this statement here. And the statement says we can return the answer in any order, so this here can be 1 and 0, right? So this is acceptable, and the constraints, the array can be from 2 to 10 to the power of 4. This 2 here is important for us because we can start if we have this array here, right? We can start from here. We can place I here, j here, right, without problem, because we know we will have always this size of 2 elements. The other constraints tells us about the algorithm runtime complexity, so we can use n to the power of 2 here, big O of n square, but we want later to do a solution with O of n. Okay, so let me open the IDE, and I have placed the input here for the second example, for this one, and I'm calling here from this class the method to sum. Let's write the logic. We will brute force here, so we will iterate. First we will start at 2. Let's see this example. Okay, 3, 2, 4. Our solution will be pretty simple. For an interview, just go for a solution and later try to optimize it. Don't try to optimize the solution from the first time, because you end up without solution at the interview. And it is better to have a solution and to tell the interviewer about your second solution, which is better. And if you have time, you can try to implement it, but you have an accepted solution. So yeah, it is the better way. Just solve it somehow, right? And here we can see if we place I and J and do the brute force, we will first check I with all these numbers, and 3 plus 2 is 5, so it's not the target value here. Okay, then we will see 3 plus 4, we are iterating that, right, is 7. It is not equals to 6. Then in the second pass for I will be here and J will be here, and now those are the indices, right? This is 2. And now I and J have the values 2 and 4. They end up to 6. So the sum of 6, so 6 equals 6, our target here, and this is our solution. But you can see we should, what this means is 3 is not in our solution. When I moves one time, then this is not in our solution for sure. If there are more elements, when imagine we have some big array here, and the I pointer is here, this means those are not in our solution. But we will nest 2 for loops, and this will be n squared time, right? But this is the more easiest solution, so let us write it. So in this case, we iterate through to the end to the array, and the J will start from I plus 1. I want to extract those two. Sum. Okay, we can see here, if nums of I plus nums of J, our sum is equals to the target, we can return here the indices, because we want the indices, not the actual values here. And we should return a new array, because you can see here the output. The output is array, the input is array, and the output is array, where the values are residing. Here they are the 0 and the first index. Here they are the first and the second index, and so on. So this will work. If we don't find anything, we will return null or empty array. I'll return null for now. Let's go into debug mode to see this. Now we are looking at this example, the example 2. So you can see the first time the sum will be 5, excuse me, 3 plus 2 is 5. And the sum is not equals the target, which is 6. Now, I will be at 0 index. So what we are doing here, 3, 2, 4. The first time we have checked this 3 plus 2 is equals to 5, which is not equals to our target value here, right? Now J is here. 3 plus 4 is 7, which is not 6, right? So now I will move forward. You can see here, if I put the indices here, we are at I is at 0 and J is at 2. Now what will happen when J is at the end? I will move forward. Here I will write it. I will draw it, sorry. Now I will move here and j here because we say j is equals to I plus 1. And we can see clearly that 3 is not in our answers, right? And now we can see here, let's move through the debug. We can see the answer is coming. Now you can see in the debugger I is 1, j is 2, right? I is 1, j is 2. And here you can see 3, 2, 4. You can see here we are pointing here with I and j, 2 and 4. 2 plus 4 is equal to 6. Our sum here. And the target, we are searching for 6, so the target is 6. And we have the answer, right? We will return now from the method. And we will return new int array with I and j, the pointers, which are at 1 and 2. We return it and we print it for debugging purposes. Okay, 1 and 2. Let's see the answer here. 1 and 2. I didn't pick this example because here from the first iteration we will get the answer and I cannot explain it this way. So let's try. I'm not sure if we should return no, because if we don't return from here, if there is no such sum that adds up to the target value which we have as inputs, here we will return no. Maybe we should return empty array, I don't know, I don't remember. But let us try this. Let's run it. Okay, the first cases are passed. When we click submit, we will try to pass all examples. Okay, we have passed it. So you can see here we beat only 31% in runtime performance. This is poor because we are using solution with 10 square time and this is not good. So let's try to optimize it. How we would do this? We should get rid of this second for loop here and we will get this time right. When you see these kind of questions, try to think about this part here, how to get rid of the second loop, how you can avoid it, right? So our second solution will be by using hash map as some tricks. So we have, let's take some example. Let's go to the description. We have, let's take the example 3 to 4 again. Believe me, this is the better one for explanation. Okay, imagine we have a hash map here. Hash map. And we want to iterate just once, right? Now we have only I pointer. We don't have j pointer because we will have one for loop to get to this n time, not n square. So we use the advantage that we use hash map and we are here and we will say this. If we are here and our target, our number to find, sorry, our formula will look like this. NTF, we will abbreviate this by NTF. Our NTF is equal to the target value, which is 6, minus the current element we are standing on, which is 3, but this actually is, if we say this is nums array, this is the naming, this will be nums of I, right? And let us see now. The target is 6, the first value is 3. We have 3, right? We will put this 3 in the hash map. Because this is not the answer, right? Okay, then we are going to the second element here. I is pointing at 2 at index 1. And what we have now? 6. First we check if this number is in the hash map. And no, it's not, right? So we apply the formula. And the target minus the current element is 4, right? We put this 4 here. And what this means, the first time when we was here, sorry, on the second iteration, if 3 here is not in our hash map, then this is not in our answers, right? Like in the 2 for loops iteration, if I have passed this value, it's not in our answers. So we are now at the third iteration at index 2, right? And we say first, before applying this formula, we say, hey, do we have this number into our hash map here? And we can see this number is in the hash map. What is this means is we found a number we should match with this number we are currently looking on. We are at number 4, right? We are at number 4 right now, which resides here at index 2. And in the hash map there is 2, but how we calculate this? We have this 4 here. We are at 4, and we have this answer in the hash map. But how we calculate this 4? By subtracting 2, right? And if we put this 2 here, voila, 4 plus 2 equals to 5, right? So by this technique, we will know when we have the answer, because in this iteration here, when we are standing at index 1, we have calculated the target minus the current number, and the current number is 2, so this is the answer. But in the map we have put the subtracting the target from the current value, we put it in the hash map, and you can see if we move the 2 here, this is our second element, right? 4 and 2 lead us to 6. So those two guys. And now for 4, when we have calculated 4, we have calculated with 2. So we will put the key 4, but the index will be 1, and we will have the index from the previous element that will match the answer. It resides at index 1, and we will have the current element index because we are at it at this moment, which is 2, and we will return 1, 2, right? Let's see if this is correct. 1, 2. Okay, so let me write this solution for you. So I get rid of this for loop, right? I need to define a hash map with two integers for key and value. Okay, so I'm start iterating here. So I first need to see if the map contains the answer. And the answer will be, sorry, just a second. If it contains nums5, right? If it contains it, I will return the, okay, let me for now comment out this because the AI assistant is stupid in this scenario. So we check what we check here. Imagine we are at the point 3 to 5 is the input. Okay, 3 to 5. Let's think. We are here and we want to search the hash map, right, for answers. But we first should see if the answer is, if the number is in the hash map, the answer. So let us calculate it first. Int number to find NMF is equals to the target value minus our current value. This will be the target is 6. Okay, so what we want is the target will be 6. So here we say target minus the current value here, and we will put this value in the hash map, right? So we will put this value and we will put the index as the value, and the key will be this abstraction here. So this will give us the answer, but if we find some number such that it matches this condition, what I mean, okay, it's a little trick here to explain it, but we have 3 to 5. Imagine we have put 3 in the hash map, and now we are standing here and we will search for this in the hash map. Okay, we will do this here, and when we calculate for 2, we will have 6, the target, minus 2. We will put 4 right here, right? And when we are standing at the last element here, it will be in the hash map and we want to return from here. So if the map contains 4 in our case, because we are standing at 4 here with the I pointer, if the map contains it, this means we have the answer, right? Otherwise, we want to put this in a else block, right? And from the else block, we want to calculate. We want to calculate these values here and put it in the hash map. In the hash map, we are putting the number and the index. So we put, imagine this, we put if it is 3, we have 6 minus 3 equals 3. This is the target value, this is the current value, and we put in the hash map as key the value, and e is at index 0 here. Okay, we put the 0 index because we will need this when we return the answer. So we put here the value, the number to find value, which is calculated by subtracting from the target the current value and put it in the map. And if the map contains this value from the previous calculation, on this calculation we got 6 minus 2, which is 4, right? And here we will be in this case because 4, the current element which we are standing on, will be in the hash map, and we know the answer is correct if we are in this if statement, right? Sorry, it's a bit tricky to explain it, but if you have questions, ask in the comments, I will explain it again. But from here, we want to return what we should define an int array, right? Sorry. You should define an int array, returning directly from here. We should get from the map the current element, right? We search the current element, and this is the first element, and we should return the current element index. So this is just I, right? Okay, and let's extract some of the code in variables because this one liner here. Now what we do? We get the value, right? Okay, and this I here is, you can see, just the index from the for loop. So this is much better for reading. So again, if we don't find the answer, we return null. Let's now put it in debug mode to see what is happening. Okay, now you can see we have 3 to 5, right, as an input. Three to four, excuse me. We have 3 to 4. Now, you can see here this first statement is equals to false because our hash map is empty, and we say, hey, do we have 3 in our hash map? No, we don't have it. So please calculate me our number to find. So we are going into the if statement, and we subtract the current number 3, from the target, which is 6, and 6 minus 3 is equal to 3, and we put it in the hash map, right? So you can see number to find is 3 here, right? Okay, we put in the map those values, the index in the value. Okay, now I will open the map. You can see we have added 3, and we have 0 here for the index here. Okay, now we are at the second iteration. In our case, we was here. Now ice at 0 at the first index, sorry. Okay, and we again check, hey, is this number in the hash map the number 2? We search the number 2 in the hash map. No, it is not there. So this is not our answer. We know 3 by now is never been our answers, right? We are sure about this. And you can see the advantage here. If we are brute forcing using 2 for loops, we should check all the elements. Now when we make one step, we know if the previous value is in the answer. By now we know, without iterating from here the whole array, it can be very large array, we know this element is not in our answer. So you can see how we go to all n time now, right? Now we are going into the debugger. Now our number to find is 4, because we have subtract from the target value this element here which are standing on, which is 2, and we got the number 4, and we have add this 4 in the hash map. Okay, and we will put this 4 in the hash map, and we will put here 1 for the index, because they want us index to be in our answer. So let's go ahead. Now is 2, you can see. And at this point, we are asking in this if statement, we ask, hey, does this 4 is in our hash map? And like you see here, it is 4 is at index 1. Okay, if it is there, what we do is we get the value from the map, and the value is the index 2, the index 1, sorry. You can see this way. Here is the hash map. So this result here is gained here by subtracting 2. So if we put 2 here, 4 plus 2 is equal to 6 to the target, right? And now we return the here is the value from the map, which is the index, right? Index where we find this 4. And the I is the index of the current iteration, and the current iteration is at index 2. So the answer will be 1 and 2 here, right? We return the array from here. Okay. And like you see here, our result here is 1, 2. So Is it correct? Is it correct? One, two. So we can proceed here. And okay, let's try now this solution. You see here we have one for loop and a hash map. We will sacrifice memory for the performance, but the performance is more important in the algorithms in this solution, so we don't care so much about the memory in this case. Now let's run it. Okay, passed. So let's submit it. And you can see now we almost done 100% of beating the other solutions. The memory, it's the same, I think. We use a hash map, but yeah. You can see here is 2 milliseconds. Even I can try to submit it again. Okay, it is around 99% and 2 milliseconds for Java. So let's analyze complexity. Voila, often. And we were for the first solution we were here. O of n squared, right? You can see we are now here, which is acceptable solution. Okay, and this is for this problem. I'll put the problem in the description of the video. I hope you like the optimized solution and you understand it. I hope I explain it good, but if you have questions, ask me in the comments. And if you want to solve some other problems, again, tell me in the comments. So bye guys, and have a good day or good night, and be successful and happy. Bye.